Hello students, welcome back. In this video, we are going to expand on our core mechanic of our game. Our core mechanic are these radioactive cells that appear all over the battlefield that we can push around as our player. In this video, we're going to take those radioactive cells, and when they explode, not only are they going to deal us containment damage, but they're also going to leave a nuclear residue where they exploded. That nuclear residue, if the player moves through it, will drastically slow them down, making it harder for the player to maneuver around the battlefield. It's going to be harder to contain other exploding cells if we hit that residue. So let's dive to our computer screen, and we'll head right in. So I have lesson 7 starter file open right here. All right, our mechanic expansion of radioactive residue. And I'm just going to minimize this file, minimize vscode.dev, and I'm going to open this file directly now in the browser so we can see those changes. So here is lesson 7. So let's take a look at what we've got here. So I'll hit enter. All right, let's see. Our cells spawn. All right. We've got that nice color lerp going on as they transition from one color to a next. We've got that flash animation, but right now we have no residue, zero residue. So we have to sort of implement this system. Every place where a cell is exploding, we want to leave that residue behind. So let's look at our mission checklist here for lesson number 7. Mission number 1, it says we need to adjust the residue system constants. So it seems like anytime we implement a new system into our game, the first thing that we try to do is define some data for that system. So if I hit Control F to bring up my search bar and I search the tag mission 1, and I hit the down arrow right here, it's going to bring me to mission number 1. And if we look, where is this in the scope of our program? It's right here in the student edit zone. This is where we have all of our constants that we can use to define and tweak our gameplay. So what are we looking at here for the residue system? Well, I have a constant variable called residue radius. How big do I want the explosion residue to be? And if you notice, I'm using a radius here. A radius is a measure of a circle. So this implies that we are going to have a circular residue that the player could potentially move through. So right now it is set to 1. That's a super small value. Let's change it to something that I've play tested and I think works pretty well here, and that is 30. We also have a player slow multiplier. So when we move through a radius or a nuclear residue, our player is going to slow down. It's going to slow them down as they trek through this nuclear waste. And so this value here is going to be something that we multiply by the player's speed to slow them down. Well, right now it's set to 1. So imagine if the player's speed were 5. Well, 5 times 1 is just 5. Their speed would be unchanged. And if I had made it, I don't know, like 1.5, well, that would make the speed greater, right? 5 times 1.5 is going to be 7.5. Their speed's going to go up. We don't want that to happen. So what we need to do if we want to decrease the speed is multiply by a value that is less than 1. So I'm going to make this player slow multiplier 0.40. So when we are moving in the residue, we are going to take the player's speed and multiply it by 0.40. Now, I don't know, what is 5 times 0.4? Let's just see. 5 times 0.4, it's going to make it 2. I should have known that. I should have known that this was going to be 2. So it's going to take their speed and drop it from 5 down to 2, if that's what the player's speed is. Is the player's speed still 5? Let's just take a look. Player speed, oh, that's right. We converted it into time-based, so it's 300. Though I was in the old system of frames. Ew, gross. We've changed that system. We are now in a DT system. All right, but the idea still stays the same. We're going to take our speed of 300 and we're going to multiply it by 0.4, and it's going to reduce the speed when we move through the nuclear waste. All right, mission 1 is in the books. Nice work, nice work. Before we head to mission 2, which is right here, let's just see what other variables we have to work with. So I'm going to go back up. So here's our student edit zone, right? We've got our residue constants, and then on our color palette, it looks like we're adding some colors for our residue. We've got a ring color, a fill color, and a core color. Note we're using RGB alpha strings because we are using some transparency values so we can see behind them. And now outside of the student edit zone, we've got some gameplay variables. So what variables for our game do we need for this residue system? Well, I have a variable called residues, which is an array, because if you think about it, we're going to have lots of residues popping up along the screen, right? For every cell that spawns in the game, there could be a residue here when this cell explodes, and a residue here, and a residue here, and a residue over here. So we're going to have multiple residues. We need a place to put them all, and we're going to put them inside of this array. And then we have a variable that's keeping track whether or not a player is actually in a residue. And we set it to false. Because if they're not in a residue, we're going to keep their speed exactly the way it is. But if they are in a residue, we'll multiply by that player slow multiplier, reducing their speed throughout the game. All right, now that we know our game variables, let's jump to mission number 2. Because mission number 2 puts us right into that function that we've seen before, reset game to defaults. So when we start the game, when we restart the game, if we've died, we got to make sure everything gets back to the way it was. And in this mission, we are going to reset our residue variables, those 2 variables that we just looked at. So maybe we died and there were, I don't know, 5 residues scattered throughout the battlefield. We want to make sure we get rid of them all because it would be unfair for us to start the game with 5 residues remaining. So we're going to do residues, there's the array, and we're going to redefine it as an empty array. We're just going to empty that container completely out. And then we're going to assume that when we start the game, we are not inside of a residue. So we'll say player is in residue. I'm going to hit tab to autocomplete is equal to false. All right, so our mission is complete. Our residue system variables will be reset for us. So right now, if we run this though, I mean, we're just defining data. Nothing is gonna appear. We've got no residue here, right? I'm not gonna slow down, nothing yet, because there's a 3-layer system at play here. We have to define data, update data, and draw data. And right now, we are just doing one of those things. We're beginning to define the data. So let's move on to mission number 3. Ooh, look at that. We've got to generate our residue data. So we've sort of seen this before. I'm going to scroll up. Like with our cells, we had a generate cell data, spawn cell, and update cell. So we've seen this trio of functions. We generate the data, we spawn the data, and then we're updating the data. So we're going to do something similar here with our residues. I have a generate residue data function, a spawn residue function, and then it looks like I got check player cell collisions. I don't have to update the residues because once they're created, they're not going to do anything. So there's no updating them. So let's look at our generate residue data. It says complete the residue data object. Store the position for each residue zone. All right, well, right now it looks like we're just returning an object that has 2 properties, an X property and a Y property, and those values are 0 and 0. I don't think that's quite right because what that's going to do for us is every time we spawn a residue, it's going to spawn it at position 0, 0, which is the top left corner of our screen. That's not what we want. Absolutely not. But if you look, this function is going to take in 2 pieces of information. It's going to take in an X value and it's going to take in a Y value. If you think about it, let's get a cell here. When this cell finally implodes, this cell has an X and Y coordinate, and we're going to spawn a residue at that particular location. We're going to spawn a residue at that cell's XY coordinate, at that cell's XY coordinate. We are going to pass in those XY coordinates into this function, which means here we're going to set the X property of our residue as the X value that we pass in. So we're going to make this X. And we'll set the Y value to Y. And just like that, our residue data is complete. That's pretty slick, right? It says, so this is the property of the residue, and this is the position that we're going to set it at. All right, this is the property of the residue, and that is the position that we're going to set it at. Where are we going to get these positions from? We're going to get them from the cell that has just imploded, from their XY positions. All right, mission number 3 in the works. All right, so we're still all in this generate data. Now it says we need to spawn our residue when a cell finally explodes. Because you saw it, right? Our cells exploded. Look, I'm dead. No residue is being created yet. So mission number 4 puts us in update cells in the update cells function. So the update cells or the update cell function, remember we have a timer now that is attached to our cell. We're decreasing it by dt. If our timer is, this is for a spawn timer. If our spawn timer is less than or equal to 0, it's time to spawn a cell, and then we reset the timer. But then we also have another timer, a timer that is attached to each individual cell object. That is the timer it's going to take for the cell to explode. And when that cell's timer is less than or equal to 0, it explodes and we take containment damage. So we did this in one of our previous videos. But now we want to do one other thing here when the cell has been triggered for an explosion. We want to spawn a residue. So I have a function that can spawn a residue. It's called spawn residue. And I'll just scroll down. Let's go look at it, right? We looked at generate residue data. When I call spawn residue, I got to pass in an X and Y value. And then we take that array that we looked at earlier, which was empty, called residues, and we use the push method on it, which means we're going to put something at the end of that array. And what are we putting at the end of the array? Whatever is returned from the generate residue data function, which is right here. It's going to be something that has an X position and a Y position. So we just have to pass in the correct X, Y values into spawn residue. So I don't know. What do we want to pass in? Well, let's think about it. If I passed in 100 and 100. So that would mean every single residue that we spawn would be at X coordinate 100 pixels in, Y coordinate 100 pixels in. It would always spawn right there. They just spawn right on top of each other. We do not want that to happen. Instead, we want to spawn a residue wherever a cell has exploded. So if you look, we are already working with a cell that has exploded. We reached into our array cells and we grabbed the cell that was at position I. Right? It would work backwards. So if there's like 5 elements in your cell or in your array, it would be position 4, then 3, then 2, then 1, then 0. So we're going to grab that particular cell's X position and its Y position. So let's look. We'll say, all right, cells, there's my array, square brackets, I reach in and I grab what is at index I. That represents a radioactive cell that sits in our game, and we're going to target its X property. And I'll do something similar for the Y property. I'll do something similar for the Y property. Cells, square brackets, I dot Y. Now, there's only one small problem here. When we target a cell, the cell's X coordinate is the left side of the cell. The cell's Y coordinate is the top. So that is going to put us in the top left corner. So when I spawn my residue is a circle. The circle is going to have its center point be this top left corner. So it's really going to spawn like shifted up here. I don't really want that. Instead, I want the circle to spawn with the center point of the circle being the center of this cell. So what I need to do, given my X coordinate, I have to shift in half of the cell size, right? So there's the cell size, I'm going to shift in half. Given the top, I need to shift down half of the cell size to find the center of my cell. So let's add that here. When we spawn our residue, we're going to do the cell's X position plus the cell size variable divided by 2. That's going to shift me in half of the cell. And then we'll do something similar in the vertical direction. I'll do plus cell underscore size divided by 2. That's going to shift me down half of the cell. And so now when we spawn a residue, the XY position that we'll pass, no matter where that cell is going to be the dead center of the cell. Hey, mission number 4, done. Is anything happening yet? Let's just check. I want to see some residue. I think maybe some magic's going to happen. Let's just check. I'm going to move this so it's, I'm going to try to move it. Let's see. Get it dead center. Let's see if we have residue. Nothing. And of course, you're shaking your head. You probably know. And it's because we have defined the data. We are updating data, but we have to draw the data. We haven't drawn this residue yet. And if we go to mission number 5, it puts us inside of a function called draw residues. All right. And if you look, where is this? We're next to like draw cells, draw goals, draw background. In fact, in our draw scene function, which we're running every single frame of our game, we call draw background, draw goals, draw residues, draw cell, draw player, draw HUD. And if certain conditions are met, we are going to draw the correct overlay screen. So draw residues is getting called. It's just that nothing's really happening. So what are we doing here right now? Well, we're saying no stroke. Give me an invisible marker so you don't see the outline of the shape that I'm about to draw. And then we loop through all of our residues. So remember, this is our container, our array that holds all of our residue objects, and we're looping directly over it for const residue of residues. So remember, in this array, maybe I got residue 1, residue 2, residue 3, residue 4. When we loop using this method, we start at the beginning. So this variable, residue, will be our first residue. Once the loop is over, we'll go to the next iteration of the loop, and residue will be res2. Then it would be res3. Then it will be res4. And I can do all of my operations on every single thing that is inside of this array. So what are those operations going to be? Well, we need to draw the radioactive residue zones. The first thing I'm going to do is I'm going to put a color in my paint bucket. So I'm going to say fill. And I think we had like 3 different colors. So residue, what I got? Core color, fill color, and ring color. I'm going to start with ring color. It's going to be like probably the outermost part of the residue. And so now I'm going to draw a circle because I'm going to use circles for my residues. And if you remember, each residue object has an X position. But you got to spell residue right. Residue.x. And it has a Y position. Residue.y. And then we had a variable, I think it was called residue radius. Residue radius. All right, so I'm just gonna, let's just see. I think now we should at least be able to see this. I got to get rid of my, my array that I wrote here for learning purposes. And so now let's just see if these rings start showing up. All right, let's see. Zoop, 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 zoop. Got to wait 2.5 seconds. Okay, there we go. Now I got to wait another 8 seconds for it to explode or implode. I think explode is probably what's happening. And do we get a ring? Hey, look at that. We get this little transparent ring. Now, that's way too small for me. So the ring is not maybe what I want to keep as the, I'm going to make the ring, I'm going to make the residue radius times, we'll make it, I don't know, I'm going to make it bigger. I'm going to do 2.2. So that's going to scale that out much bigger, and then we'll put other parts of the residue inside of it, like its fill and its core. That should work pretty good. Let's just see. That should be a lot bigger. Yeah, that's pretty good. So if I'm trying to move through there, I'm going to slow down. And you can see these things are spotting up all over the battlefield. It's pretty cool. But our graphics aren't done yet because we also have a fill and a core color. So let's put another paint in my paint bucket. Fill. And next I'll do residue fill color. And we'll draw another circle. The circle is going to be centered at the exact same spot. Residue.x, residue.y. And then we're going to make this circle a little smaller. So I'm going to do residue underscore radius. And I'll multiply by, I don't know, 1.8 here. So that's going to be a smaller circle. And then we've got our core color. So we'll put one more paint in our paint bucket. Fill residue underscore core underscore color. And then we'll make another circle. Circle residue.x, residue.y. And this circle will make even smaller. So I'll do residue radius. I'll multiply by, I don't know, 0.95 here. All right, so now let's see the residue completely. We got 3 different colors, 3 different sized circles. Our residue should look a lot better. Let's just take a look. I'm going to move this guy right down to the center of the screen. Zoop. Let's move this one down too. Let's see. Ooh, look at that. I really like how that looks. All right, so we're drawing these. Look at these things are popping up all over the place. Our battlefield is getting dangerous. As I'm trying to move around here to contain these reactor cells, it's going to slow me down. So that looks really great. Of course, the slow me down functionality is not working at all. So now we got to look at that. So mission 6, we have to now detect when the player is actually inside one of these residues. Essentially, when is there a collision between the player and the residue? And so we've sort of looked at collisions already, but we looked at rectangular collisions between the player and the cell. if you look here, our residues are not rectangular. Our residues are circular. And so this makes it a little tricky because I have a circular object and a rectangular object. So how am I going to detect their collisions? Well, I either have to assume the circular object is a rectangle or assume the rectangular object is a circle. Those are the two easiest ways. And so what we're going to do is we're going to assume the rectangular object, our player, is actually a circle. And we will do circle-to-circle collisions. So to help us with that, I'm going to actually go to the whiteboard because I know everybody loves math. And we're going to draw a little picture. So let me grab my my tablet here. And so the first thing I'm going to do is I'm going to say, okay, let's just assume, where's my pen? Okay, I'm over here. Let's assume here's my player, right? Here's my player. Zoop. I'm going to assume that this center point defines a circle that encompasses the player, that has some radius, okay, r. And so I drew that poorly, but you get the idea, okay? And that radius is going to be the player's size. Player size. All right, and so now let's look at what would happen if we have the player, zoop, and here is a residue. Let me do a residue in a different color. I'll do a residue in red. So here is my residue, okay, so my residue. They are a certain distance apart from each other. There's a distance apart in the x direction, represented by this arrow. I'll call that dx. And they're a distance apart in the y direction. All right, so I'll draw that arrow, and I'll call it dy. And those two directions are 90 degrees to each other. The actual distance they are apart, though, is represented by, if we're here, and here is represented by that line, zoop, right here. And that line is the hypotenuse of a right triangle. I'll call it len for the length of our distance, how far away we actually are. So what we got to do is we got to figure out how do we determine what that value is. Well, there's a nice known formula. It's called the Pythagorean theorem. And so I can say the Pythagorean theorem says we call this side of our triangle A, this side of our triangle B, and this side of our triangle C. It says that if you take A and square it and add B squared, you get C squared, the length. All right, so that's pretty good. So now we have a way to determine how far away our player is from a residue if we know dx and dy. We just square dx, we square dy, and we add them, and we have this distance that is squared. Now, what happens? Are we in a collision right now? Absolutely not. Our player is really far away from the residue. But what happens if we move our player here? No, we're still not in a residue. What about right here? No, we're still not in a residue. But I'm going to zoom in. What if we were here? And right here, we just overlapped. Now we are in a residue. We have a collision. So those distances are represented by this size, this radius, and the residue's radius. Okay, we're going to call that length right here, this length, our hit zone, because as soon as our distance apart gets less than our hit zone, it means we have had a collision. All right, so let's see if we can write this out, right? This right here represents our distance apart, and I'm going to substitute in. That's dx squared plus dy squared. So that represents how far apart we are. If that is less than or equal to maybe our hit zone, which is, let's see, r is the player's radius, but the player doesn't really have a radius. Remember, it has a size. The player's size over 2, right? Because the player's size is this whole length, so we're going to cut it in half. So that is player size over 2 plus the radius of our residue, plus the residue's radius. So plus residue radius. Now, there's just one small problem. See, we wanted to compare this length right here to our hit zone, our value right here. But we're not comparing it because if you look, this is c squared. So I could either take the square root of this side, and that formula will work nicely, but But taking the square root's kind of a pain. So, it's sort of computationally intense. So let's not do it. Instead of taking the square root of this side, let's just square this whole value. So we're going to take this whole value right here, and let's square it. Of course, that whole value is what we refer to as our hit zone. So I can just write dx squared plus dy squared is less than or equal to our hit zone squared. If that is true, if this is true, then it means we are in a residue. There is a collision, and it's time to slow ourselves down. So that's the math here behind our circular collisions. So let's see how we can implement this here in mission number 6. So we're in a function called check player residue collisions. So what are we doing first? Well, we're getting a variable called player center x. So this is the center in the horizontal direction. If we look, we take its x coordinate, which is the left side, right? The left side here. And then we add, bloop, half their width. So that's going to be right in the center. And then we do something in the vertical direction as well. We get their y value, which is the top, and we add half of their size. So now I have the coordinates for the exact center of the player. I need that because if you look at our whiteboard drawing, we had to figure out that distance right there starting at the center of the player to give us a circle that encompasses the player. And now we're looping through all of our residues that are on the board, and we're going to check to see if the player is in collision with any of them. We get a dx value by taking the player's horizontal center and subtracting the residue's x position. All right, so if we look here, we're taking the player's x position and we're subtracting the residue. So that's our dx variable. Then we do something similar in our dy direction. We're subtracting the difference between the player's y position and the residue's y position. And then we calculate something called our hit zone. Our hit zone is the residue's radius, bloop, right here, plus the player's radius, roughly, which is the player's size divided by 2, what we said. All right, so we've got all our variables. The Pythagorean theorem told us that, hey, our length can be found as dx squared plus dy squared, and if that is less than our hit zone squared, it is time for a collision. So this is what we're asking. We're saying, hey, is there a collision? But look at what our question is asking. It says if false. False is always false. So the answer to this question is never going to be yes. Our code is never going to run. So we're going to ask a question in here that could be yes, it could be no. And it's going to be, is the player in contact with the radius? Or with the residue. The way we check that is we take that dx variable and we square it. And then we add the dy variable squared. And that represents approximately how far away we are from a residue. And we're going to check to see if that is less than or equal to our hit zone variable squared as well. All right, so now if that is true, right? If dx squared plus dy squared is less than hit zone squared, then we are overlapping. Where are we? We are overlapping like right here, and that means it's time to slow us down. And look at what we do. We take our player is in residue variable and we set it to true. Mission number 6 is done. That was a bit of math, but hopefully this is great because now we've seen rectangular collisions and circular collisions. Let's look at mission number 7. What happens when we are in a residue? Well, we got to slow ourselves down. Now, we already started by at the beginning of this video by looking at our player slow multiplier. Right now, if you look, our speed multiplier is just equal to 1. There's a nice thing. When you multiply any number by 1, it's still the same thing. So if you look here, we're adjusting our player's x position and our player's y position by getting their speed and multiplying by time. We had set up that relationship in an earlier video, but we're taking the size of that speed and multiplying by our speed multiplier. So if we look right here, you can see how fast I'm moving. Let's make that speed multiplier, I don't know, like 0.4. That was, I think, what we said our low speed multiplier was going to be. So now if I restart the game, maybe I got to refresh the page. I'm moving much slower. This is how fast I'm going to move when I'm inside of a residue. But right now I'm not in a residue, so I should be moving my regular speed. Somehow we have to say, hey, is the player in a residue? If it is, set its speed multiplier to 0.4. If it's not, set it equal to 1. And there's a lot of ways we could do this, but we're going to introduce something known as a ternary operator. We're going to ask a yes or no question, a true or false value. And that true or false value is going to be the variable player is in residue. When we started the game, we set it to false. When we detected a collision with a residue, we set it to true. This is known as a Boolean value. If this is true, we're going to put a question mark right after this, which is the ternary operator, which says, hey, look at this question. Is it true or is it false? And then afterwards, we're going to put what we want to set this variable to if the result of this question is true. If they are in a residue, we're going to set our speed multiplier to, I think it was 0.4, but we're not going to hard code it as 0.4. Let's use our variable, player slow multiplier, tab to autocomplete. And then we'll put a colon. The colon separates the answer to this question if it is true. So if this is true, we're going to set our variable speed multiplier to this value. And what we put on the other side of the colon is what we would set this variable to if the answer to this question is false. And that's how the ternary operator works. If it is false, we're not in a residue. We're just going to set the speed multiplier to 1, because if you multiply anything by 1, the speed will remain unchanged. Now, our system is, I think, pretty operational. Let's take a look. So I can move around, zoom in. I'm zooming. Let's let something explode. Those are sound effects. All right, let's see. Let's move through, and I slowed right down. Oh my God, but I'm forever slowed. That's not good. I don't think that's the right behavior. As soon as I hit, I slowed down and I never got my speed back. I hope you saw that. So something is still broken because the speed multiplier should be set back to 1. But the only time the speed multiplier is going to be set back to 1 is if this question right here is false. And maybe perhaps we are never setting it back to false. So let's check mission number 8. In our check player residue collisions, it says we need a state reset. We're going to reset the residue state each frame. This will ensure that slowdown only applies while inside of a residue. Because if you look right here, if we collide with a residue, right there, we set player is in residue equal to true. Nowhere in here are we setting it back to false. So at the start of this function, we will assume we're not in a residue. We'll set player is in residue equal to false. If, lowercase, there we go. We're going to set it equal to false. So we're going to assume we are not in a residue, and then we're going to check every residue there if there's a collision, and only if there's a collision, then we'll set it to true. Now, we will have reset this, so our speed should go back to normal. So let's check it. I think we're done. Let's play test this. Let's see how this residue system is working. All right, I can score some goals. Let's let something explode. I'll let it explode way out here. All right, let it explode right here. I should slow down as I move through this and then speed right back up. So like if I want to move this guy, oh no, I slowed down. Oh no. Oh no, there we go. Awesome. Perfect. This is working. Exception. Oh, geez, I got stuck. All right, I am super, super happy with this. Okay, so I think our mechanic expansion lesson is complete here. We did a really great job of adding another really great layer, another great system to our game. And it builds on, and there is synergy between all of the other systems that we have in place. So now our reactor cells, not only are they unstable, not only do they detonate, but they now leave a hazard in their wake. And that hazard can slow us down, making it harder for us to progress through the game. This is perfect synergy between all of these systems that we have going on, and I'm really happy with how this has turned out. I hope you are too, and I can't wait to see you in our next video.